Welcome to Crashcast Java, where we dive deep into Java programming concepts. I'm Victor, and today we're exploring the volatile keyword with my co-host, Sheila. Are you ready to unravel this intriguing aspect of Java concurrency?
Absolutely, Victor. The volatile keyword is a fascinating topic that often confuses Java developers. Let's start with the basics. What exactly is the volatile keyword, and why do we need it?
Great question, Sheila. The volatile keyword in Java is a field modifier used to indicate that a variable's value may be modified by multiple threads. It's primarily used to ensure visibility of changes to variables across threads.
That's interesting, Victor. Can you explain what you mean by visibility of changes? It sounds a bit abstract.
Of course. Imagine a bulletin board in an office. When one person writes something on it, everyone can see it immediately. That's similar to how volatile works in Java. It ensures that when one thread updates a volatile variable, all other threads can see that change right away.
Ah, that makes sense. So it's about making sure all threads have the most up-to-date value of a variable. But why is this important? Can't threads just read the variable's value directly?
Well, Sheila, in modern computer architectures, CPUs often use caches to improve performance. Without volatile, one thread might cache the variable's value and not see updates made by other threads. Volatile prevents this caching, ensuring that reads and writes go directly to main memory.
I see. So volatile is about thread safety and preventing race conditions. Can you give us an example of when we might use volatile in a real-world scenario?
Certainly. A common use case is for flag variables in multi-threaded applications. For instance, imagine a long-running background task that can be stopped by setting a flag. You'd want that flag to be volatile to ensure the background thread sees the change immediately.
That's a great example, Victor. Now, I've heard some developers confuse volatile with the synchronized keyword. How do these two differ?
Good point, Sheila. While both deal with multi-threading, they serve different purposes. Volatile ensures visibility of changes to variables, but it doesn't provide atomicity or mutual exclusion. Synchronized, on the other hand, creates a lock that guarantees both visibility and atomicity.
I see. So volatile is lighter weight but doesn't protect against all concurrency issues. Are there any limitations or pitfalls developers should be aware of when using volatile?
Absolutely. One common misconception is that volatile alone can make compound actions atomic. For example, volatile doesn't make operations like I++ thread safe because it involves multiple steps: read, increment, write. Also, overuse of volatile can impact performance due to the overhead of always reading from and writing to main memory.
Those are important points to keep in mind. What would you say are some best practices for using volatile? And are there alternatives developers should consider?
Great question. As a best practice, use volatile only when you need visibility and don't require atomicity. For more complex scenarios, consider using atomic classes from the Java util.concurrent atomic package or higher-level concurrency utilities. Also, always document your use of volatile to make your code's intent clear to other developers.
Thank you, Victor. This has been a really informative discussion. To wrap up, could you list 3 advanced topics related to volatile that our listeners might want to explore further?
Certainly, Sheila. For those who want to dive deeper, I'd recommend exploring 1. The Java memory model and how it relates to volatile. 2. Using volatile with the double-checked locking pattern. 3. The relationship between volatile and the happens before guarantee in Java concurrency. These topics will give listeners a more in-depth understanding of concurrency in Java.
Excellent suggestions, Victor. And that brings us to the end of today's episode of Crashcast Java. We hope our listeners found this exploration of the volatile keyword informative and engaging. Remember to subscribe for more deep dives into Java programming concepts. Until next time, happy coding.